Hello and welcome, my dear grade 11 advanced math students, to my channel Mathematics Made Easy. I welcome you to today's session, which is going to cover the most important questions from your EOT. Now we are beginning in this video with learning objective 3, where you are going to write logarithmic expression in exponential form and write exponential expressions in logarithmic form. In today's session, we are going to be covering questions 1 to 21 given on page 265 of your math notebook. So let's get started. Okay, so before we begin solving the questions, let me give you the key concept which is going to help you to solve these questions 1 to 21 very easily. In this key concept, we will learn how to convert logarithmic expressions to exponential form. And you may use this formula to do the vice versa, means you can also convert exponential form to logarithmic expression the other way around using this key concept. So I want you to understand it very nicely. First thing I want you to remember is that logarithmic function always has log, L-O-G. This is the way we write it. And this log has a base and it has a number. Now this value, let's assume it is equal to y. So this is the logarithmic expression which has log form. And we can convert it to exponential form and vice versa. How do we do this? So exponential form, exp, just remember this, means it will have a base. So the base here is b and it will be raised to a power or an exponent. And this value is going to be equal to x. So this is going to be our key concept that we will use. This is the logarithmic expression, this is the exponential form, and we are going to do this conversion by using this key concept. So now we are ready to solve the questions. In this slide, we'll be covering 1, 2, 3 questions. So let's see what is happening here. So in each of these parts, you have log, log, log given. So that means logarithmic form is given. So we are going to convert it to exponent form. So let's see how we do that using the key concept I just explained to you. So log bx equal to y. So let's compare. What is b? B is your base, 15. X is 225. Y is 2. Now I gave you in the last slide the formula to convert log to exponent. So it is b to the power y equal to x. That means for this question 1, the exponential form is going to be this form. So let's put the numbers now. B is 15, y is 2, and x is 225. So that completes the solution. This is the exponential form of question number 1. So we were given the log and we converted to exponential form. Let's do similarly for the next question. So in this question, if you compare, the base is 3. The value of x is 1 over 27 and the value of y is minus 3. So again, I use the same formula. This is the exponential form. We have to convert it to that one. So b to the power y equal to x is your answer. Let's plug in the values. 3 to the power minus 3 and x is 1 by 27. So this is your final answer. Now I'm going to go fast and we will do this in a very quicker way, quicker solutions. So b to the power y equal to x, this is your exponential form. Value of b, which is your base, is 5. Value of y, which is the number here, is 2. So 5 to the power 2. That is going to give you the value which is here. So 1 over 25. Now here there is a mistake. It has to be minus 2 because when you raise 5 to the power minus 2, only then you get 1 over 25. Okay, so this is a printing mistake in the question. This log value is equal to minus 2. Just be careful. And then yes, this is your final answer, the exponential form for question 3. So now that you've understood the concept well, we are going to go fast and we will apply the formula very quickly. So b to the power y equal to x is your answer for the exponential form. Base here is 3, y here is 5, and x here is 243. So this is your final answer. Similarly for this one, base is 4, y is 3, and that's equal to 64. So this is your answer. And last but not the least, for this question, the base here is 4, the value of x is 32, and the value of y is 5 over 2. So we apply base to the power y is going to be equal to x. So that's your solution. I hope you've understood the key concept for these kind of questions. Okay, so now we need to do the opposite of what we have done till now. In these questions, if you see exponent form is given, we need to convert to logarithmic form. The key concept remains the same, so let me write it here for you. So log to the base b x is equal to y gets converted to b to the power y equal to x. Now we are going to use the opposite of this because this time this form is given and this is the one that we need. So this is the right formula. Let's compare and get our b, y and x for this question. So the base here this time is 2, the power here y is 7 and the number x is 128. So let's plug in everything in this and get our answer. So the final answer for question 7, the logarithmic form is log base 2 x 128 is equal to 7. So that's your answer. Let's do in a similar way solution for question number 8. So here your base is 3, your power which is y is minus 4 and x is 1 over 81. So directly now I use the formula, this one. That means log base x is equal to minus 4. So yes, this one is my logarithmic expression, which is my answer. Let's do the last one similarly. Now I'm directly going to use this formula because we are now comfortable with log question. So log the base is 7, the value of x here is 1 over 49 and the value of y is minus 2. So this is your answer. Let's do a little bit more practice and solve question 10, 11 and 12 in the next slide. Okay, so let's now solve the same questions. Question 10, 11 and 12, we'll use the same key concept. So here you are given each of the questions in exponential form. We need to convert to logarithmic. So we are going to use the key concept that if b to the power y is equal to x, we are going to convert into logarithmic form in this way. Okay, so let's do it. So here your base is the number 1 by 7. It's a fraction this time. The power, which is y, is 3 and your x is 1 by 343. So let's use this formula because now we need log. So I will write log base x, which is 1 over 343, is going to be equal to the value of y. So y is 3. So this is your answer. Let's now do the next one. So here the base is 2, the power y is 9, x is 512. So we will use the same formula and our final answer will be log 2, 512 is equal to 9. Now I will directly proceed to the answer for this question because now you know how to do it. So log base is 64. Your value of x is 16, so this is going to be 2 over 3. So that's your final answer. I hope you've understood how to convert log to exponent and exponent to log with these questions 1 to 12. Now we'll proceed with some more questions. What is different in these questions is that you need to evaluate them. Evaluate means find the value. So in this case, if you look, each of these functions are logarithmic function. So step 1 would be to assume this value to be y and then trying to find y by converting to exponent form. So the same formula I gave you before is going to work. So let's see this. So here the base is 2, x is 64. So let's convert it to exponent form first. So exponent form tells us that it will be 2 raised to the power y equal to 64. Now here the two bases are different, so we have to make it equal. So how can I write 64 with base 2? What should come as the power? Check, use your calculator. Yes, you're correct. If you multiply 2 with itself 6 times, you will get 64. That means 64 can be written as 2 to the power 6. Now we'll apply the property of equality, which says that if the two bases are equal, the value is equal, then the powers are also going to be equal. The exponent are going to be equal. So that means y is equal to 6. Therefore, the question was asking you this value. So your final answer is log 264. Its value is equal to y, and y is 6. So this value is also 6. This is how you solve it. Let's follow the same method. I will put this equal to y and now convert to exponent form. So in exponent form, it will come out to be the base is 100. So 100 to the power y is equal to this big number. Now let's count how many zeros it has. 1, 2, 3, 4, 5. So I can write 10 to the power 5. Now 100 also I can write as 10 to the power 2. And already there is a y, so both get multiplied. Now again, are we able to apply the property of equality? Let's check the bases. Yes, they're equal. Let's check the values. Yes, they're equal. So will the powers be equal? 100%. So 2y equal to 5, and hence your y is 5 over 2. You may convert it into decimal or leave it as fraction. Both are correct. So that is your final answer. Therefore, the value of log 100, 1, 0, 0, 0, 0. This big log is 5 over 2 or 2.5. Now I hope you will be able to proceed in a similar manner for this question. So let's go a little fast. We will convert it directly to exponent. So we get this value. Now I need to write 625 with base 5. So if I multiply 5 with itself 4 times, I get 625. So 5 to the power 5 is equal to 5 to the power 4. Again, property of equality, bases are equal, so powers are going to be equal, so y is 4. So the final value for log 5625 is 4. So I hope you understood how we can evaluate each logarithmic expression using property of equality for exponential function and get our answer. So now I want you to try these questions 16, 17, 18 yourself and check your answer. So for question 16, this value, if you put it equal to y, then y will come out to be 4 over 3. And for this question, question number 17, the value of this logarithmic expression will come out to be negative 5 over 2. So this is a little tricky one. Let me do it for you. So let's assume log 4 1 by 3 by 2. Whatever log expression you need to find, first take it as equal to y. And then you convert it into exponent. So when I convert to exponent, the base is 4. The power is y, that's equal to 1 over 32. Now, if you see carefully, both are very, very different. Here you have 4, here you have 32. So we need to make them equal. We need to make them equal to a common number. So can I write 4 as 2 square? Yes, I can. Similarly, can I write 32 as some power of 2? It is 2 to the power 5. Now you see the common base. So let's convert this. 1 over this means reciprocal of a positive exponent. So it will become negative power. And now we are ready to compare because both have the same base and the value is equal. So property of equality can be applied. So y is going to be minus 5 by 2. This was an important question. And in a similar way, you will be able to solve question number 18. Now observe here question 18 has a decimal. So you will be able to convert this number 0.0001 into exponent with base 10. So let's do this one also. It's important. So first I convert to exponent form. So this becomes 10 to the power y is equal to this decimal. Now I'm going to rewrite this decimal in exponent form. So 1, 2, 3, 4, 5. 5 decimal places. So can I write it as 10 to the power minus 5? Yes, and I'm sure you know why I did that, because I wanted to make the bases equal and apply the property of equality. So now I can do that very well, and I know y is minus 5. Therefore, the value of this logarithmic expression log 10 0.00001 is equal to minus 5. That's your final answer. So now I will be just providing you the final answers for questions 17 to 21, and I hope that you will be able to get to the correct answer yourself. This value of log will come out to be 3. Similarly, for question 20 and 21, if you solve it correctly and apply the definition of logarithm, use your property of equality, you will be getting your answer for this question as 0, and for this one you will get it as 2 over 3. So let me show you a few steps for question 20. So here, if you apply the basic definition of log and take it equal to y, you will be able to convert it into an exponent in this way. Now see, here the base is 9, here the number is 1. How do we make them equal? It's not easy. So what we are going to be doing, we will write this as 9 to the power y, and this one we will write as 9 to the power 0. Now you must be wondering, why did I write 1 as 9 to the power 0? The reason is because I want to make both the bases equal. So now that the bases are equal, I can apply the property and say that this value is 0. Always remember 0 exponent property. That's what I use here. Any base raised to the power 0 is always 1. That's why you get this value. Okay, wonderful. For this one also, follow the same steps and you will be getting the correct answer. Convert 4 and 8 as base of 2 and you will be getting 4 equal to 8 to the power y when you convert this to exponent, and further you can write this as these values. So now that I convert 4 and 8 with the same base 2, I can make the powers equal. So 2 is equal to 3y, or y is 2 by 3. So that is how you reach to this. So with that, we've come to the end of today's session. In this session, we covered learning objective 3 and learned how to convert logarithmic expression to exponential form, and opposite also, that exponential expressions can be converted into logarithmic form. We also found how to find the value of each logarithmic expression, and I hope this video helped you in your journey of learning mathematics. And if it did, don't forget to like, share and subscribe to the channel. Press the bell icon for receiving the notifications for my upcoming grade 11 advanced revision video. Until then, this is Ms. Ruchika signing off from today's session, wishing you all the best for your coming math exam. See you in my next video. Bye-bye.